because if people actually wanted to get it. Yeah, so
Mm-hmm.
we are live. So
Awesome.
hey everyone, we're live here in Vegas profile to talk about a little bit the Mono Blitz. So if you have any questions and you really wanted to take up with, we're with Harpo. He's the dev from Monad, and he's here for us to explain a little bit more about Monad. So if you feel comfortable to do some questions, ask us, because here's like our hitting up for the event on Monday on Sunday. Sorry about it. So here's Elton. The stage with Elton. No, sorry, Harpo. So here we're with Harpo. So the stage with you. So it'll be fine for you to introduce yourself, to start the presentation first. And thank you for the for accepting the invitation as well.
Yeah, thank you. Thank you for having me. Hey all, I am Harpal. I'm part of the DevRel team at Monad Foundation. I've been working a year at Monad for almost 1.5 years now, and I've been seeing all the photos and videos and tweets from the Monad Blitz that happened in Rio. Looking forward to the Sao Paulo Blitz as well. And Yeah, it's on Sunday, so make sure that you're there, you're present. It's a pretty cool experience. It's a 1 day get together, building, making friends, and having fun. But today I'm here to give you a little bit info about what Monad is, how it works. This presentation will also be given to people who attend Blitz as well. But for people who are not going to be able to make it to the Blitz event, I can give you a small overview of what Monad is, what are the different opportunities we have, what are the different tools we have, and what are the different types of things that you can do on Monad. So let me just quickly share my screen, and let me know when my screen is visible. Is it visible?
Yeah, now it is. Yeah.
Awesome, cool. So yeah, let's get a brief overview. Let's learn what Monad is. I'm sure some of the people are interested. Some people might have some misconceptions on whether Monad is an L2, whether it is even compatible or not. People who are going to be participating in Blitz, they might have some questions about which type of tools are supported, etc., etc. So feel free to drop those questions. We will take them somewhere in between the presentation or towards the end. Cool. So the agenda for today is understanding why we need high throughput blockchains, right? What is the reason for them? Are there enough users? Are there enough apps? People keep joking about the ghost town, or like Web3 has a lot less users, etc. But that's really not true. I'm going to show you a few charts and show you that there are a lot of users using Web3 apps, including on Monad and other chains. Then we're going to talk about what Monad is, why did we think of building it. Then some things for developers, specifically like tools and services, opportunities, etc., and tips for presentations. So the tips for presentation is specifically for people who are coming for Blitz. And to really quickly give you an idea what Blitz is for people who are either going to come or not going to come. It's We start at 9 a.m. in the morning. We do breakfast, we do presentations, and then until 12 p.m. And then you have 6 or 7 hours of hacking. And towards the end, you present the projects that you have built, and the other participants vote on which project was the best. So there is a presentation at the end that you have to do about the project that you made. So I'm going to give you a few tips that will help you to make your presentation best. Cool. So the need for high throughput blockchains, right? On-chain activity is exploding, right? Not just like regular apps, but like stablecoin supply is increasing. There are so many DePIN apps coming on. Prediction market volume is completely off the roof. Millions of billions of dollars being spent in prediction markets. Now it's going to be increased even more in the coming weeks, because there's some baseball tournament happening in the US, which is going to bring in a lot of value or volume as well. Perps trading volume is also over the roof. I think there are so many on-chain dexes which are performing better, and perp exchanges performing better than centralized exchanges and providers, because you have the flexibility of using assets from different chains. You don't have to worry about token support or chain support, etc. You can just bridge assets from other chains and use them. So there is a lot of demand. There's a lot of people using it. Even if this is a bear market, or sort of such a situation, there are just a lot of people using, and there's a lot of volume happening in Web3. um, to give you a few use cases, in the past, and even today, Uniswap is one of the best options out there, right? But back then, when Uniswap was there were only a few people who were using it, and like whenever there was a small token launch, the gas prices used to spike so high that it almost became unaffordable to use Ethereum mainnet, right? These days, it's much better. Because of the optimizations and the things that have been happening on Ethereum and other chains. But Uniswap was there back in the day. MakerDAO, which is the creators of the DAI token, Synthetics, CryptoKitties, which was a very popular NFT collection back then. Which got a lot of people into crypto and NFTs. But now we are moving on towards the future where there are much more high performance apps, right? Like Hyperliquid is there, Polymarket is there, Kuru, which is one of the Monad projects, Mio Digital, Kizzy, USDC. These apps are doing a crazy amount of volumes, and they have a lot of transactions when it comes to placing orders, canceling them, various different strategies that are being used on these platforms by experienced traders, which involve placing a lot of orders, canceling them, and matching orders and providing liquidity and market making, etc., which requires high throughput blockchains, right? You cannot do such high performance tasks, or like high speed tasks without having a high performance blockchain. um, so the question is the blockchain infrastructure ready for the upcoming demand? Not just the current demand, but there, as we build more and more apps, as we discover more and more use cases for crypto, right? Over the time, we discovered that DeFi is a great use case of crypto. Another one that is coming up is machine payments, right? Like AI agents using crypto rails as a way to pay each other and doing business, or sending transactions is something that is picking up. And when these AI agents or machines will start doing payments and transactions, they will do it at much faster rates than humans. And it is very likely that machines transactions are going to surpass human transactions very quickly once it picks up, right? So let's talk about some numbers where we can estimate what type of performance do we need, right? On Ethereum, current Ethereum throughput, capacity is 60K gas is what an ERC20 transfer takes, and 5 million gas per second is what Ethereum processes right now or can process, and that is up to 7.2 million transactions or transfers per day, right? And comparing that to a web to rail or like a web to service provider, Visa does 700 million transfers per day, which is a lot when compared to Ethereum. And we consider Ethereum as part of our world computer, right? We want everybody to be using Ethereum, and Visa is just one of the providers, and it is still 100 times ahead of what Ethereum can process right now. And then we can compare it with swaps as well, because one of the applications, as I mentioned, is DeFi. Swap is one of the simplest action a trader can make, and 150K gas is consumed on doing a simple Uniswap trade. And as I mentioned, 5 million gas per second is the Ethereum throughput, which means we can only do 2.9 million trades per day, compared to NASDAQ, which is just one of the exchanges in the world, does 60 million trades per day. And Ethereum is something where trading happens 24/7, right? Which means it's supposed to be much, much higher than the traditional options that we have right now. So by looking at these numbers, and these are today's numbers, everybody is thinking that we need a chain which is much more faster, decentralized, accessible to everyone, neutral to everyone, and be also able to compete with these Web 2 alternatives or Web 2 service providers like transfers, Visa for transfers, Nasdaq for exchanges, and many other options that are available out there, right? And then we can do a napkin math here, where let's say there's 10 apps with 1 million users, which is very common in the Web2 world, and everyone on that app performs at least 2 transactions per day. That requires 231 TPS. That is 8 times what Ethereum can do right now, right? So Ethereum is very decentralized. It has a lot of TVL, it has a lot of apps, but it's still not there when it comes to giving that performance that is needed for the demand. So the bottleneck is not new apps, but the infrastructure that lets these existing apps scale, right? If these apps get a lot of users won't have a really good experience because the underlying infrastructure is slow and is not capable of serving that many users, which is why we built Monad, right? We want a scalable, secure, decentralized solution, all in one. And that is why we have built Monad. It's much more faster than Ethereum and comparable to Web2 service providers, and it is decentralized. And we are doing our best to keep up on security as well, right? So we are going to learn how Monad is built. What are some important parts of Monad that make it this fast and this decentralized, etc., etc. So to quickly summarize what I've been talking about, Monad is EVM compatible and is high performance chain, right? Many people, and I've seen this as a developer, I talk to a lot of builders and developers, and many of them complain that, even if I build an app, the underlying chain is just so slow that sometimes I wish that I should just start building on Solana, right? The reason for people not going over to Solana that easily, I personally feel, is somewhere around developer experience that I have seen firsthand, but it is also improving over time. However, the community of EVM or the Solidity language community has been much more stronger. The tooling is much more mature, and there are just so many people who have participated in this community that you can find answers for a lot of things that you get stuck on. There are many people that can help you out, and EVM has just been around for a very long time, that it is much more battle tested compared to like other VMs, right? So we get EVM compatibility on Monad, and we get high performance, which is like the best of both worlds, right? You get to use the same tools that you have been using all this time if you have been building on EVM chains, but you get high performance just by deploying your app on Monad. So what is Monad, right? A lot of people might be thinking that Monad is an EVM L2, but it is not. It is a fully EVM compatible L1, which means all the tools that you have been using, like Hardhat, Foundry, Alchemy RP services, the graphs, subgraphs, Gold Sky, any solution, any service provider that you have been using to build your EVM apps works out of the box, right? You just have to check if they support Monad or not, which I think they should. Most of the popular service providers support Monad, and the Ethereum RPC is the same. As I mentioned, the tooling is also the same, and you can use Solidity to write your smart contracts and deploy them in Monad. So comparing Monad to Ethereum surface level, Monad does 500 million gas per second, which is 100 times more. Block times are much faster, so 0.4 seconds is a block time, which means whenever you're sending a transaction, it gets included on chain in less than a second, and you get a confirmation in almost a second, right? So that is really good UX, right? When you're paying someone, if you're at a shop, you're paying someone, and you want a finality or like the green check in your app, and the receiver also wants strong confidence that they have received the payment, and there is no way for a reorg or the state to change in less than a second. That's a good thing, right? Because that is what naturally how payment should be. You shouldn't be waiting there for like 12 seconds for the chain to finalize your transactions. Actually, not even 12 seconds. It's actually more in case of Ethereum. But you don't want to be waiting around, right, just for your transaction to confirm. So this is what Monad provides. Monad does 10,000 transactions per second, and this is 10,000 generalized transactions, meaning that it could be a mix of transactions. It does not have to be plain transfers. It could be swapping, NFT minting, putting an order on an order book, matching orders, or it could be transfers. It could be anything on chain happening. And at that point, even if a mix of transactions are happening at the same time in a single block, you could expect 10,000 transactions per second speed. And it is decentralized. We have 170 validators. Ethereum compared has about 13,000 active validators validating the blocks and everything. Cool. So you might be thinking, okay, if Monad is decentralized, how do I check it, right? So you can go to this website called gmonads.com. This website is information of all the validators, their locations, which blocks they have been proposing, leader schedule. You can even do staking, you can do delegation, etc., right? So this is a singular portal for validators. You can see who the validators are, the current TPS, if there are any blocks which are being timed out, etc. You can see all of that on this website. Cool. So the goal at Monad was understanding how can we raise the limits of the blockchain with new software architecture, right? We don't want to go into hardware. The reason is because we can have the best hardware, and just by simply raising the hardware requirements, it's very easy to build high performance blockchains, right? But the problem is that hardware is not available to everyone. And not just that, actually, even right now, after the open clock race, even Mac Minis and Mac Studios are out of stock in many places, right? So becoming a validator can, for a very high performance chain, can require much more specialized hardware, which is even more difficult to get, right? And not just Mac Mini and Mac Studio, but even RAMs are so expensive now. After AI companies have started grabbing them from pretty much everywhere they can find. Right. So the goal was that how do we keep the hardware requirements to a minimum and get the maximum output in the form of a high performance blockchain. And also preserving decentralization, right? Decentralization is because people can participate in the validator network, and for letting people participate, you need to keep the requirements reasonable. If you have very high requirements, it's just impossible for most people to participate. But that's not the case in Monad, right? And if you want to know about what the hardware requirements are, please check out our docs. Docs.monad.xyz has information about the hardware requirements on how to run a validator node, how to run a full node, etc. Do we have any questions before we move in?
Yes, we do have two questions here. The first
Okay.
one is from Crypto Joãozinho. It's Little Joe's crypto Twitter. Actually, he asked him the transactions are parallel, but how long do the confirmations take?
Yes. So the confirmations take about 2 blocks after your submission of transaction. So in about 1.2 seconds, you get a confirmation that your transaction is confirmed, as in finalized, right? You get inclusion notification in zero point 0.8 seconds and 1.2 seconds for finalized transaction notification. So after 1.2 seconds, you can be sure that your transaction is final. Nothing can change. Like no reorgs or state cannot change. So
Yeah,
that's how quickly you get it. And we're going to learn about how transactions are executed in parallel in the future slides. But yeah, we can take the next question as well.
oh, that's good because he made another question just like for the answer of it. Like, are there separate layers for execution and confirmations? Because
So we do have separate logical layers for execution and consensus, and we're going to talk about it right after these slides. So I'll probably just go into the slides and talk about the slides, so you will get your answer there. If don't, just put the question again, and we can help you understand it better.
yeah,
Cool.
for you guys to know a little bit, just a little bit here, Harpo. In Rio, we had a developer that was talking like, I'd never seen a transaction so faster than this before. Even Solana doesn't reach out like these faster results that Monad have. So one of the
Totally.
projects was from ZK, and then I can present to you a little bit better later about like how the projects were in Rio and how you guys can think about like creating some different stuff so over Monad later.
Totally. Yes. Cool. Let's jump into the architecture. Essentially, learning about what are the different pieces of Monad. that make it monad so fast, and why do they do it and how do they do it. So one of them is asynchronous execution. This is basically the answer to the question. We are doing consensus and execution as different processes. I'm going to talk more about it in the coming slides. Optimistic parallel execution is essentially executing each transaction in the block in a parallel manner. We're going to learn about this as well in the upcoming slides. And MonadDB is a database built specifically for blockchains. So how we can efficiently store blockchain data into a database, how to efficiently read it, write it, etc. We're going to learn about this as well in the upcoming slides. Monad BFT is a performant consensus algorithm. The algorithm is different because, as I mentioned, the block time is 0.4 seconds. 0.4 seconds is the time in which they have in which the leader has to like send blocks to all the participants and get them to vote on the block, right? Whether the block is valid or not, right? And it has to be done very quickly, which is why we need a different algorithm than what Ethereum uses. Raptorcast is an efficient way of sending those blocks, right? We're going to learn about this as well, but there's a lot more information in the docs as well. Essentially, Raptorcast, what it does is that when the leader has a block, it divides it into small parts and then sends different parts to different peers that it knows, right? Rather than sending the full block to all the validators, it sends chunks to validators, and then the validators can take all the chunks that they receive from their peers and construct the block back again. This helps with network bandwidth. It's very interesting. I recommend Googling Raptorcast. We also have a full blog on how it works. So if anybody is interested, feel free to take a look. JIT compilation, or just-in-time compilation, is a caching technique where if you have been to Etherscan or any Explorer, there is a tab for popular contracts, right? What it means is that these contracts are being involved in transactions a lot because a lot of people want to interact with these protocols or want to do a lot of transactions. One of the example could be Uniswap, right? Everybody wants to swap, and whenever they swap by Uniswap, the Uniswap contracts automatically become popular on the Explorer. And what JIT compilation does is that it caches the code, which means that over time, the validators and the consensus process and the execution process understands that, okay, a lot of people are using this contract again and again. Why don't we keep it ready as in the cache, so that whenever a new transaction comes in, I can quickly take the contract code and execute the transaction. So these are small parts, but they contribute together. When we bring them up, they contribute and make the chain a lot more faster, right? Every small piece of the architecture contributes to performance, and when we bring them together, the performance increases a lot. Cool. So let's learn about asynchronous execution. So to give you an example of what happens in other chains is that in Ethereum, you have 12-second block times. What does it mean? It means that the validator or the leader right now has the time to construct a block, get votes, execute transactions, everything in 12 seconds. No matter what, in 12 seconds, a block has to come out, right? And when we, if you use some monitoring tools, you will find out, or if you are a validator, you will find out that most of the time of this 12 seconds is just spent in consensus. Why is it spent in consensus? Because consensus is the process where you are sending blocks to other validators, right? And if that algorithm of sending blocks and the way you send it is not efficient, then it takes a lot of time, because this is happening over the internet, which means you need faster internet connection. The receivers also need to have a good enough internet connection to respond back with votes and whatnot, right? So what the Monad team observed was that Ethereum has every validator has 12 seconds, but out of that 12 seconds, 99% of the time is spent in consensus, and only a very small percent of time, which is about 100 milliseconds, is available for execution. This is what is a bottleneck, right? So how to explain it, or how to visualize this, that if you have very small time for execution, then you cannot accommodate a lot of transactions in the same block, right? If you have a lot of transactions, execution will take more time, And if execution takes more time, then consensus might not complete. And if consensus is not complete, then blocks won't come out in the 12-second time frame, which could be a major issue, right, for Ethereum. So how can we get more time for execution so that we can accommodate more transactions? And the Mono team thought, what if we separate these two processes into different swim lanes, right? So for example, what we do is that we only do consensus, and then after and within the next two blocks, the validators are supposed to respond with the execution results. So consensus happens in zero point 0.4 seconds, and validator results come as quickly as possible after the consensus process completes, right? So the execution of transactions happens after consensus process. So I'm going to talk more about this, or if anybody has any questions, feel free to reach out. And then there is a lot of information in docs as well. But essentially, to quickly summarize, what it means is that since consensus and execution happen in a different as a different process, they are separated, we get more time for execution. And if we get more time for execution, we can do more transactions in a single block, and hence it gives us more throughput, right? Because the end goal is that how do we do more transactions in small amount of time. So this is one of the solutions to that, and it is one of the components that is used in Monad. So yes, if it is confusing, feel free to ask questions. Also, don't hesitate to look at the docs after the presentation as well.
Yeah, sure.
So that is,
We had just a
yes.
question here from Bidding Bao. He asked here on X, like, how does Monad handle concentration of power among the validators?
Yes. So I think that is based on their stake weight. So every validator participates in the consensus process using staking, and based on their staking amount, I mentioned Raptorcast, right? How it takes a block and divides it into different parts. So depending on how big your stake is, you receive more of those parts. So you're responsible for more parts, and when you get those parts, you have to give it to all the other peers that are in your network. So peers is like, I am surrounded by 5 people, and one of that 5 person is surrounded by other 3 or 4 people. So we, not everyone is sending information to everyone. Instead, it is, I know my peers, I'm going to send information to them, then they forward that information to their peers, etc., etc. That is how the block propagates over the network. So the power concentration of power is decided by the stake weight, and you can check out gmonads.com website where you can see all this information.
Yeah, I received another one on my private WhatsApp, and the
Mhm.
question is, the MEV was a big problem for other networks. How Monad deals with it?
Um, so one of the vulnerabilities that Monet fixes is tail forking. It is some sort of MEV. No, there are many different categories of how MEV can work, and different types of things that can be done. Again, Monet is not completely MEV resistant or MEV proof, but there is one a specific one which we call tail forking, where what used to happen was that some validators have the ability where they could uh, on purpose express that I haven't received a block from one of the previous leaders, right? Like I haven't we haven't seen that block confirmed or being sent by that leader. And what they do is, since let's say for example we two are leaders, and Bernardo was a leader in the previous round, and I am a bad validator or leader, I could say that, hey, Bernardo in the last round never proposed a block, I did not even see it. And at that point, what I will do is I will propose my block for my round, but I will also propose a block for your round as well. And what does that mean is that not just that you, Bernardo, won't receive the rewards for your round, but I will receive your rewards, and I will receive the rewards for the current round for which I was responsible. um, Again, this can be confusing, but essentially it is a way of making it difficult for your previous validator to get their rewards that they deserve. And then a monad BFT is built is a consensus algorithm built in such a way that avoids this. So the concept is tail forking, which is the vulnerability, and you can read monad BFT blog, and you can learn how monad BFT solves that. So yeah, that is one of the MEV vulnerabilities where validators are attacking each other for rewards. One example where monad shines. But yeah, there are many other like MEV techniques and things that can happen, not just on every chain, but yeah, there are like on monad as well.
Yeah, I think this is the questions until now, but I think
Cool.
people will start typing again here on the comment sections later. So feel free
Awesome.
for you to ask the questions for Harpo.
Yes,
So
feel
that's
free to
it.
ask questions. But yeah, I think we should. I will keep continuing. Once we have like 3 4 questions, we can take them all at once.
Okay.
Awesome. Cool. So the next thing I want to go over is optimistic parallel execution. So the previous one was separating consensus and execution. This one is about executing each transaction in parallel fashion in the same block, right? So many of you might have heard about this. Many people call this parallel EVM. Optimistic parallel execution is what we call. There are many other names for this, but essentially. This is the concept, or this is the way that monad does it. And to give you a comparison, in Ethereum all transactions are linearly ordered, right? Transaction 1 2 3 etc etc, and then they are serially executed. So even if transaction 4 is a very simple transaction, it cannot be executed before 1 2 and 3 are executed, because it's just written, the algorithms are written in a way where Ethereum has to execute them serially, right? So what monad does is that, what if we could keep the serial ordering just like Ethereum does, but we do the work behind the scenes in a parallel fashion. Now we're going to understand with an example how that can happen. But you can imagine, let's say there's a single lane road, and all of a sudden there are like 5 lanes, and now all of a sudden there's no traffic. People are able to reach to their destination quickly, and this is comparable to like getting the transactions quickly confirmed and whatnot. To take a simple example, let's say we are at some block in the blockchain, and there were some blocks before this block. We have 4 transactions in a block, and the state before this block came in is that I have $1,000, Alice has $0, Bob has $300. And looking at the 4 transactions, because we can see it on the screen, we can quickly calculate that this is the expected state, right? Like this is what we expect after all these transactions are executed, and the result should be that I have $800, Alice has 100, and Bob has 400, right? So now how do we get from before to the after state by executing the transactions, and how do we do it in a parallel fashion? So what we do is we first decide the inputs, right? To execute a transaction, you have an input, then the transaction is executed by the EVM rules, and then we get some output. So for first transaction, we give input that I have $1,000, Alice has $0. We execute the transaction, and we get an output, $900 for myself, and Alice has $100, right? Second transaction, it's an unrelated transaction. Unrelated meaning it does not involve me, Alice, or Bob. It could be someone else on the blockchain doing something else. It could be NFT minting, placing an order, swapping, etc., etc. Right? And when we are on this presentation, when I am speaking to you, I am speaking one by one for each transaction. But in reality, all these transactions are executed all at once, right? All of them are executed at once, and then we get the outputs. So for transaction 3, which is me sending $100 to Bob, we take the input. The input is $1,000. Bob has $300, and then we execute, and then we get the result that I have 900 and Bob has $400. And the fourth transaction again is an unrelated transaction. So you can see we took the inputs from the state that we know, and we executed the transactions parallelly, and we got some outputs. Now, are these outputs correct? So if anybody in the audience is paying attention, do you think this is correct? Is there any mistake on the slides? What do you think? Does anybody want to quickly respond in the comments on what the mistake is?
Nobody text here. Let me see on my WhatsApp if somebody answered.
Yeah,
No, nobody
let's
still
give
now
it five
have answered.
seconds.
Yeah. We have like 120 people online now.
Nice. Cool. For this one, I will just move ahead to making sure we are completing this on time. But essentially, first transaction, there's nothing wrong, right? Like everything is correct. The output is what we expect, so we can commit it to a final state. So this outputs column is intermediate and committed state is the final. Um, so for second transaction, it's unrelated. It cannot affect other transactions, which is why we can also commit that and consider that as final as well. The problem is in the third transaction, right? Most of you might have already realized it, but the problem is that when we executed third transaction, the input was $1,000 for me, and then Bob had $300 already, and then we calculated the output, and the answer was that I have 900, Bob has 400, which is incorrect, right? Now you might be wondering, why was this input incorrect? Well, that is because when we were executing these transactions, we were executing them parallelly, right? And when you are executing parallelly, you don't know how the state is going to change in between the transactions, right? So we took whatever input we knew when we were executing this transaction, and that input was the final state of the previous block, right? So the details below the before title that we have, right? I have $1,000. That's what we know. So we use that input, and then when we were committing final answer or the final state, we got to know that there was a mistake that was made when we were executing transactions parallelly. And how do we solve this mistake? Very simple, right? Now that we know the latest results or the current input, the correct input, we can simply use that input and execute transaction 3 again with the right input, right? So we now use the right input, and since we use the right input, we quickly execute the transaction and we quickly get the correct output, and then we can consider that this is the new final state and this is the correct one, and then we can move on, right? So to summarize, we execute all transactions parallelly with whatever input we know, and then we find a mistake, and then we re-execute it with the correct input, and then we get the correct output. So that's simply how parallel execution works. It's very simple, but it's so powerful, and it contributes a huge chunk to the performance that Monad provides. So yeah, I'm happy to take any questions or doubts people have. But yeah, if not, we can move on to the next concept.
Yeah, people didn't send any now, but
Okay,
I hope they send like really soon.
cool. Okay, awesome. Um, okay, cool. Let's really quickly learn about what MonadDB is. So as I mentioned before, MonadDB is a custom database to store data on disk. Um, so what happens in other chains is that they use a database which was not created specifically for EVM or blockchains, right? To give you an example, when you are doing web 2 development, you have this choice of what type of database you want to use, right? You have PostgreSQL, you have MongoDB, you have vector databases and whatnot, right? Depending on what type of task you are doing or what type of app you are building, you have to choose the right database. Otherwise, it's going to be a big problem, right? PostgreSQL is for relational entities. MongoDB is for entities where you don't know how many columns there should be, so you just turn them into documents, and then you can easily change the columns or add new columns, etc. And vector databases are new. These are for AI based applications, right? So if AI based applications have vector databases, then why don't blockchains have its own database, right? Because blockchains, they have a specific data structure as well. So for people who are much more advanced or have been building for a long time, they might know about Merkle trees, Merkle Patricia trees, and whatnot. And this is a very common data structure that is used in EVM chains. Then why don't we have a very easy way of accessing that data structure and storing that information on the disk in a way that can be easily read and write, and very quickly, right? Because speed is all that matters here, right? Like how can we very quickly get the answer for something that we want, be it getting information of a specific slot in a smart contract, getting a value, getting a balance, anything, right? I mean, MonadDB is that database. It very very elegantly stores data on the disk, and you can make parallel access requests. This is also important, right? Because in the previous concept, we learned that we want to execute transactions parallelly, but how can we execute transactions parallelly if we cannot read data parallelly, right? So this MonadDB allows that, and is one of the most important parts of Monad, and it is very special. There's a lot more information on how this works in the docs as well, so feel free to check it out. But to summarize, it essentially allows efficient data storing and parallel access to that data. Awesome. So you heard a lot about like the different parts of Monad, how they contribute to being high performance blockchain. But what's in it for developers, right? Because to be honest, you actually don't need to know a lot of these things that I just talked about. That is just for your curiosity on how Monad works, what are the different components. But developers actually don't have to ever interface or involve any code that talks like that uses like optimistic parallel execution or something like that. All you have to do is just deploy your smart contracts and you get all the benefits out of the box. You don't have to change anything. Obviously you have to change the chain ID and the RPC URL in your app, but that's mostly it, right? So this is very cool tech, but what's in it for developers, right? Well, how do we improve the developer experience? So for developers, Monad supports bigger size contracts, right? That's 4 times of Ethereum 128 kilobyte size contracts. There's a contract size limit on Ethereum, but Monad supports bigger contracts. So how does that help? If we allow bigger smart contracts, you can write much more complex apps. Many teams, what they used to do is that they had big apps that they wanted to deploy it on Ethereum, and because of the contract size limit, they divided those contracts or that single contract into multiple contracts, and then they write code to connect them, right? So this can be a big problem. Why? Because cross contract calls are one of the biggest vulnerabilities and reasons for a lot of security issues that have happened in the past, right? And this is because Ethereum does not allow bigger smart contracts, so you have to divide them, you have to deploy them separately, write code to connect them, make sure that is secure, etc., etc. But on Monad, since you have bigger smart contracts that you can deploy it, you can just deploy the entire app as one contract, and you don't have to deal with cross contract smart calls. Awesome. So that's one big feature, right, for developers. Another one is a special RPC method. The name of the RPC method is pretty long, but what it allows is that it allows you to send a transaction and get the receipt of that transaction in the same request, right? So if you have been dealing with RPC methods in your app, or even if you're using like a VM or MACD or something similar, you might have seen that whenever you send a transaction, you also have to run another polling. You have to write code for polling the transaction status, right? Like whether the transaction confirmed, if it confirmed, what is the receipt, what are the events, etc., etc. So this RPC method available on Monad allows you to send transaction and get the receipt in the same request, right? This allows for much faster, snappier UI. Essentially, your user just presses a button, they send transaction behind the scenes and get the confirmation in the same request. So your app can very quickly show that your transaction is confirmed. You can move on with whatever you are doing. So that helps, right? Like if you have much faster UI, your user experience is great, and people would love your app, and more people will start using your app. Execution events, this is for much more advanced and high throughput apps. It allows you to look at streaming events, like whenever a transaction is emitting a log, or whenever a transaction is being accepted, or whenever a transaction lands in a block. All the different types of execution related events, you can get them directly by running a full node. So for execution events, you have to run a full node, or you need to have access to a full node that will give you access to execution events. There's a full guide on it in our docs on Monad, where you can find how to run a full node, how to enable execution events, how to take advantage of it, etc., etc. So these are some powerful features that allows developers to build high performance apps. And it just helps, right? If your app is pretty good, people would use it more, and they would invite more of their friends or people they know to use your app, and you will have more users. Essentially, that's what developers want, right? You build an app, and if nobody's using, it's no use. If a lot of people are using, then it gives you motivation to build more, right? So what can you do on Monad? You can use Solidity language, you can use Foundry, VM, EVM model is the same, accounts, gas, balances, TX ordering, everything works the same. Ethereum RPC, gRPC, WebSocket support, everything is the same, right? All you have to do is just change the chain ID. We have various different explorers. We have Monad Scan, Monad Vision, Social Scan, etc. So all of the explorers that are very familiar to you are also available to you. But what you can't do on Ethereum is that you get faster finality, you get a very powerful Ethereum RPC method, AI agents with on-chain states are possible, high-frequency gaming apps are possible. A lot of people build games on Monad. DeFi apps are possible, payment solutions, and this is for people who are involved in ZK and privacy. They might have come across these hurdles a lot, where you can have heavy ZK privacy solutions operate on Monad because it allows you to deploy bigger contracts. The blocks are bigger, the transactions can be bigger, etc., etc. I think there's a video. Okay, yeah, I think that video might not play, but it was about an app that we had built. It was a fun, like, little game. Let's try. Okay, let's try. Yeah, this is like a clicker game that somebody had built, and this is essentially sending transactions on every click, and it's just insanely fast. I don't think I have the link to this game, but this was something that some internal team member built, and it was basically a clicker game where you, like, enhance your character using the points that you get. So yeah, every click was a transaction right there. Cool. So what I'm trying to say is you can build very fast apps, and we have a lot of resources for that as well. There is a section in our Monad documentation called Developer Essentials. This section has pretty much everything you need: information about mainnet, information about testnet, what are the tokens and bridges that are available, how to deploy, what are the different tools, the different RPC methods, what's the difference between Monad and Ethereum, and a lot more, right? And we know that developers like to use AI tools like Claude Code, Cursor, etc. So we have a LLMs file as well. You take that LLMs file, you put it into your LLM, and it has all the information that we have in our docs as well. So you can just wipe code, or use your agentic engineering skills to build the app that you want. Another thing is that we also have our own version of Foundry. So Foundry works, but we also have Monad Foundry, which is a custom fork. And the reason for having this is that Monad has pre-compiles, which are different features. It also has a gas logic, which is slightly different on Monad. So if you're doing gas estimation, if you want to use pre-compiles that are available on Monad, then I recommend using Monad Foundry. We have instructions on that as well. And if you're using VM, then use version 2.40.0 and above. The reason for using that version is that after this version of VM, Monad testnet and Monad mainnet are available in the VM package itself. So you don't have to define a separate chain, right? For custom chains, there's a defined chain function in VM. If you're using this new version of VM package, then Monad is already in there. So you can easily import it and use it. Another thing is that many people want to build apps that involve agentic payments and X402. We are running a free facilitator on Monad mainnet and testnet, right? So use this facilitator. We have a full guide on how to use it, how to build apps with X402. And other facilitators charge you. Here, you don't have to create an account. You don't need anything. You just put the facilitator URL in your app, and you get free settlements on mainnet. 8004 is also a very popular ERC going around in the developer community. Monad supports that as well. We have a full guide on how to use it. The different smart contract addresses and everything is also available in the docs. We highly encourage building mobile apps, right? Because mobile apps are very popular, easy to go viral. People have it on their phone, they use it more. So we have resources, a lot of resources on how to build mobile apps as well. So go check out the docs. There's a section on mobile development as well. Firecaster mini apps are also supported. So if you want to build mini apps on Firecaster, there's a whole template, guides on all of that as well. Another thing is skills, right? Many people might be thinking, okay, do you have like Monad development skills? So one of the contributors to Monad port developer has built skills. You just run this command npx skills port developer skills, and I can share you the slides as well, Bernardo, so you can share it with others. But this skills has a testnet faucet inside it, all the smart contract addresses, token addresses, how to verify on different explorers, an entire wallet management using Safe is also all provided and packaged into this one skill, and it helps a lot for Monad development with Cloud Code, Codex, or Cursor. And for people who will be in person at Blitz, you will have a lot less time to build, right? You only have 6 to 7 hours. And if your idea is something which is much more complex, then these skills can be really, really helpful and make your development process really fast. So highly recommend people check out the skills. It has a built-in testnet faucet, so you don't have to like look out for testnet tokens. It has a faucet inside the skills itself. Awesome. And this is one of the apps that I built using the skill. It took me like 3 or 4 prompts, and an entire app, which was a useful app, was built using the skills. This app essentially lets you swap very low amount tokens in your wallets for something like USDC or MON. So when you have like a lot of tokens in your wallet which are like low value, like $1, $2, you can select those tokens in this app and swap it into MON or USDC. And this full app end to end was built using skills. Tools and infrastructure, we have indexers. I highly recommend using indexers. NVO, Ponder, Gold Sky, all of these are available. Token bridges, we have Circle CCTP, Wormhole, Chainlink, Jumper, Mayan Finance. All of these solutions are available for cross-chain apps. Oracle's, Chainlink, Pith, Redstone, all of the popular options available. There's also Switchboard and others as well. Wallets, all the EVM wallets work. MetaMask, Trust Wallet, Phantom, Rabby Safe, Ledger, SafePal, Privy services, Third Web, Alchemy, QuickNote. All of these are all available to you to use. So if you're trying to build something which involves something similar provided by these services, don't try to build it from scratch, right? Because it will just take you a lot of time. Why not just use one of the service providers that give you that service on Monad? Account abstraction is also supported. We have a lot of paymaster options, Alchemy, Third Web, etc. As well. And for keeping up with all this, right? Like you might be wondering, okay, I have seen this presentation, a lot of good things are happening, but how do I keep myself up to date on what is happening? You can follow Monad developers on GitHub. You will get information about the new templates, new projects that we are working on, open source contributions that you can make, new opportunities, etc., etc. Right? So follow Monad developers on GitHub, and you will get a lot of notifications about the different things that we're doing, and in the open source world. Builder opportunities, this is for people who come to Blitz or do not come to Blitz. Irrespective of that, there are some opportunities for you, or some initiatives that we are doing for developers. One of them is AI Blueprint program. Essentially, if you're building any app and it involves using AI related services, will help you subsidize the cost of those services. And we'll help you basically make sure that you are able to build what you want to build. Delta V is another initiative that we have. It's a portal, deltav.monad.xyz, or deltav.xyz, I think, where you can see all the different startups, what they're working on, what are the different updates that they're shipping. You can sign up. I highly recommend everybody to sign up. And people who are pushing updates regularly on this platform, they get access to exclusive credits, exclusive workshops, VC directory, angel directory, etc., etc. Right? So very useful for people who are thinking of taking their project to the next level and becoming founders of a project. And obviously we want to do more and more Blitz. So if anybody is watching here from outside Brazil or some other city where Blitz is not happening, please feel free to reach out to me, and we will be happy to host a Blitz in a place near you. That was about developers, how Monad works, the different opportunities. This section is specifically for people who will be attending the Blitz on Sunday. Very few quick tips about presentation. So to remind you, after you're done hacking, at the end of the Blitz competition, you will be doing presentations of what you build, how you build, and then other people will be voting for you. So here are some tips based on my experience of how people presented projects, what are some mistakes that they do, and how you can improve or be prepared. One other thing is that a lot of people show a lot of slides, right? When you go on stage, you present your project, and all, you have like 3 to 4 minutes, and out of that time, 1 to 2 minutes is just spent, or like 60 to 70% of the time is mostly just spent on slides. People are thinking, okay, when are you going to start the actual demo? We are just looking at slides right now, right? So don't use a lot of slides. Quickly move to the demo as quickly as possible, right? Just state the problem, that okay, this is the problem we are trying to solve, and this is the demo, right? Another thing is that people don't speak loudly, right? Grab the audience attention, because the audience is going to decide who gets to win the Blitz competition. So speak loudly, try to grab attention of the audience. If they are not paying attention, you can just tell them that, hey, can you pay attention? We are trying to present something that you might be interested in. Another thing is that a lot of people are obviously going to use AI for building their apps, but the problem is that they don't uh, you know make their app more polished, right? Use different skills, different prompting techniques to make your UI not vibe coded, right? If you have been vibe coding for long enough, then you can very quickly say, or when you can look at the UI and say that this app has been vibe coded, right? You see all these purple colors or these random gradients happening in the app, and you can say that this UI is definitely vibe coded, right? So how do we make sure that it does not look like that? So what you can do is you can simply go on Google and search any popular app that you like and put their name and put brand kit. So for example, you can type Monet brand kit or Vercel brand kit or Tailwind, etc. And then you can get all the colors, the typography, everything you need, and you can take that and put it into your LLM and say, redesign my app, right? And it will completely make your app look not vibe coded, make it much more polished and presentable, right? Another thing is that people fill forms during their demo, right? They have a long form that they have to fill, and a lot of seconds just go into filling up that form, right? What you could simply do is you could put placeholder values for the demo, right? Just put placeholder values in your code that show up in the form. All you have to do is click the button so that you can quickly show that, okay, this is a form, this is how you fill it. You click the button and the task completes, right? So don't waste time writing things when you're presenting in the forms, and or use clipboard, right? Like use clipboard for copy pasting values during the demo so that it makes your job easy. And if you have multiple team members, so you can form teams in Blitz. You can form team of 3 people. If you have multiple people in your team member as team members, then use one person for presenting, other person for operating the laptop. Don't switch a lot, right? Because switching also takes time. So yeah, these are just some tips to make sure that your presentation goes really really well when you're doing it at Blitz. Um, I've been talking for a pretty long time. Last section, I promise. This is about how to stay up to date on the new opportunities. So, Monad developers, as I mentioned, go follow it on GitHub. Developers.monad.xyz. This is a portal, one place to know about everything that we are doing for developers, events, hackathons, uh, new tools that are available, skills, anything, right? You go to this website, you'll be able to see what are the different things that are available for developers, where are the new events happening. The entire schedule of the different events that we're doing is also available on this website. And the best place I think is Twitter, right? Go to Twitter, monad_dev. You can follow this handle, and anything that happens for developers is announced via this handle, be it Blitz, new tooling, new skills, prompts. We are going to announce a lot of things via this handle, and you can follow this handle to stay up to date on what is happening at Monad. So yeah, that's it from my side. I think I've been talking for a very long time. So it's time for questions, and thank you for listening to me, and thank you for
Yeah.
having me.
No, okay. It's a pleasure for us to having you, Harpo. You explained like perfectly for the Brazilian crowd that it's happened that's listening to you. I received a question for a builder from Brazil that's called Leonardo, and he was asking what are the programs for people who already have been or early stage investments for startups that are using Monad. This was what you guys are looking for.
Yes, we are focusing on pretty much every sector. So if you're building apps that involve payments or involves trading, involves AI agents, all the different types of apps that you've been building, we are interested in all of these type of apps. For early stage projects, we have initiatives like Delta V that I mentioned. Right, Delta V is where you can go sign up, push updates, join the community. There are other founders like you in the community that can help you. uh, Over the time of putting regular updates, we will recognize you as a core contributor or like a contributor who's active in the community, give you access to exclusive workshops, exclusive credits for your own project. We'll get you in touch with angel investors, VCs, etc., etc. So we have a whole team who manages founders as well, or takes care of the founder community. And Delta V is one of a good way to start. There's another initiative that is happening already, which is called Nitro. This Nitro initiative, the forms are closed now, but essentially it was an accelerator program for anybody who is building projects on any chain, and they get accepted. If they get accepted in this program, they get 500K dollars worth of funding. So many initiatives are happening, but I think Delta V is the perfect starting point if you are a founder and are in early stages of your project.
Yeah, sure. So I think it's the last questions that I've received, but at the beginning, I'll really have to thank you for explaining all the details that you have on Monad. Brazilian people are really into this presentation that you've made. We reached out like 210 people online now, so I just have to thank you, Harpal, and see you guys on Sunday. But I'll give you like the considerations for Harpal. Then I'll how can I say in English? I would say bye to everyone.
Thank you for having me. It's been a pleasure. I'm looking forward to the projects that will be built in the upcoming Blitz on Sunday, and I hope I was able to help you and be prepared for that Blitz. Thank you.
Okay, guys. Thank you. See you on Sunday. I'll be there waiting you all. And as soon as we get back, I'll post a lot of how the event went and for you to understand how we can make others here happen in Brazil. So see you guys. Bye bye.